All right. Okay. Okay. Here's a meme flag. SIGPwny, we will rock you. So now we have our CTF theme, and you can get challenges.
What's going on?
Is it right? Okay. Nathan, can you also set the other challenges to public? Yeah. Oh, you did? All right. Everyone got the flag? Okay. So first we're going to talk about how password cracking works, and to do that we need to talk about hashes. So hashing is just taking like a defined input, taking any sort of input, and then you're going to run it through a function that generates a value of a fixed length, and it's going to be the same value every time that you put in for the same input. And the function is one way, so you can't reverse the original input from the hash without brute force. So here we have some examples of plain text and some hashes that are generated from the plain text. So plain text high will generate this 32-bit hash, the 32-character hash, which is 16 bytes. And then notice that if we put in just an extra I, it's going to change the hash entirely. This is called the avalanche effect. And then if we put in like a really long string, it's still going to generate a hash of the same size. The point of hashes is to generate a unique, not really unique, but deterministic value. And then you can verify plain text results. So how does hashes work? How do hashes work in passwords? So the reason why you use hashes is because you don't want to store your passwords in plain text, because if your server gets breached, then all of a sudden attackers have passwords for all your users. So instead, you store the passwords in their hash representation. So the server stores the hash 5F4, and so on. When you log in with a password, the server will take your password and generate it into the hash, and then it will compare the guessed hash with the correct hash. So in this case, our first password attempt is Hunter2. That generates a different hash from what the server actually stores. So the server will check those two hashes, and if it's not correct, then it results in access denied. And then the second password that we guess is password, which generates the correct hash. So because the hash is accurate to what the server stores, then you get access granted. So that's hashing in passwords. So how to crack a password hash? Remember earlier we said that hashing function is one way. So if you get a password hash, there's no way to turn it back into the password. And the only way to get the password from the password hash is to brute force or crack the hash. And there are 3 different ways of doing this. One is just pure brute force. So you're generating every single possible combination of letters, numbers, and symbols. And this takes a very long time. But it's the most comprehensive because it covers every possible combination. The next strategy is to use a dictionary or word list attack. So this is going to drastically reduce down the amount of guesses that you're creating. You do that by guessing common passwords, or if you know the password contains a certain string, then you can generate a word list that contains those strings and all the passwords, and then you could brute force that instead of brute forcing passwords that don't contain that string. And then a rule-based dictionary attack is like a dictionary attack, but you can easily append values, pre-append values, and it's a little bit more versatile in terms of coming up with unique passwords to try. So how do you actually compute hashes? So generating a single hash takes less than a second, but if you're brute forcing passwords, you're going to be generating a lot of hashes. So this takes a long time. It's highly dependent on your compute power, how long it takes to brute force passwords. It's a well-known kind of well-known fact that GPUs can crack passwords faster than CPUs because of how like they're based on how GPUs are designed. So if you're cracking passwords on your laptop, it's going to be much slower than if you have a dedicated server with a lot of GPUs, because compute power means faster hash computing, and yeah. So for a lot of password cracking farms, you just like have like a rig with a bunch of GPUs, or some people just rent like a high compute cloud server on Amazon AWS, Google Cloud, or Microsoft Azure. So getting into dictionary attacks, we're not going to talk about pure brute force because that's just infeasible for most cases. So you can use a pre-built word list that contains a bunch of common passwords. So the most famous one is rocku.txt. This contains around 32 million common passwords, which are sourced from various password breaches. It's short enough to go through in a reasonable amount of time, believe it or not, even though it's 32 million passwords, but that's a lot shorter than pure brute force. And it's comprehensive enough for most cases. And what you'll find is that most ETFs will use the rocku.txt word list because of just how popular it is. They don't want to make a challenge impossible by making it impossible to crack a password. And then there's also SIGPwny, which is a repository of even more pre-built word lists. So for example, it'll contain like default passwords for every single like router, or passwords, or like the top 10 million passwords from a certain source. So SIGPwny is also a good place to find pre-built word lists. Now you could use just one of those pre-built word lists, or you can create a custom word list. And if you kind of know information about the password that you're cracking, like who created it, you're going to have a higher chance of succeeding cracking the password if you use keywords that the person might use in their password. So you can use pet names, song lyrics, just keywords in general. So let's say like I wanted to crack the password for the SIGPwny server. Can someone give me like examples of words we might use in our password? Tour. Password. Sure. Like we might use like pony in our words, in our word list. We might add some of the admin names, so like Minh or Thomas or Nathan. Yeah, or we could also, yeah, SIGPwny too. So creating custom word lists requires a lot of creativity, but yeah. So here's a list of some different hashing functions, and I'll get into why you want to use different hashing functions later on. But one of the most popular ones is MD5, but that's generally considered insecure now. There's SHA-256, SHA-512, and MD5 crypt. Windows uses very specific hashing systems that are like proprietary. So there's NTLM, and then there's LM, which I will explain in just a bit. So why do you want to use different hash functions? So one reason is because based on how long a hash function takes to compute a hash, it might be smart to use a hashing function that takes a longer time to compute the hash. So for example, MD5 takes around 500 milliseconds or half a second to compute the hash. And SHA-512 takes about a second to compute the hash, which is just double of MD5. So if you're just verifying a password when you log in, it's only going to take like an extra half second to verify the password, which is insignificant. But if you're going to crack a SHA-512 hash versus an MD5 hash, it's going to take exponentially more time. So in this case, you don't want to optimize having a fast hashing algorithm, because if you have a fast hash algorithm, then password crackers can generate the hashes super quickly and crack passwords. So a hashing algorithm that takes longer to compute is going to make it more secure. In general, like there's some caveats with that. There's also the fact that certain hashes are bigger in length. So for example, I mentioned earlier an MD5 hash contains 32 characters or 16 bytes. A SHA-512 hash would contain 128 characters or 64 bytes. And that increases the amount of password hashes that could exist, and that reduces the possibility of hash collisions. And hash collisions are just like, because there's only so many password hashes that you can generate, you're bound to run into a scenario where two passwords might have the exact same hash. And so when you authenticate, you can use both passwords to pass the hash check, because you're verifying the hash, not the password. Real quickly, we'll talk about salting. So salting just adds a random string to the password before hashing. And what this does is it prevents attackers from creating a pre-built generated table of every single possible hash. So let's say I create this is called a rainbow table, by the way. So I create a rainbow table that contains the password hash for every password of length of 8 character length. So you have a fixed file that's like gigabytes in size, but it's a lot less time consuming to just check if the hash matches those hashes in the table than computing all those hashes. So rainbow tables make it easy to crack unsalted passwords. But if you add a salt, that adds a little bit of entropy. So now it adds like an extra 4 characters to the end of your password. Now all of a sudden the rainbow table is not as effective, because now you have to generate a rainbow table for all the passwords with that salt as well. So salting ensures that your password is unique, and that the hash is unique. And it makes it more difficult for attackers to mass password crack hashes. So we're going to go to a case study with how to not design a hash function with Microsoft. So earlier I mentioned the LM hash, which is used on really old Windows systems, so like Windows 2003, Windows Server 2003, Windows XP. Basically, the way the LM hash function works is it takes your password, it converts it all to uppercase. So lowercase, uppercase, does not matter. Everything gets converted to uppercase. Then it either adds, if your password is shorter than 14 characters, it adds some null bytes to the end. Or if it's longer than 14 characters, it just cuts off the rest of the password. So your password is effectively just the first 14 characters. Then it splits the password into 2 7-character chunks, and it basically creates effectively 2 hashes from each of the 7 characters chunks, and then it concatenates them together to create your LM hash. So like if you look at the top, we have the original password, really secure password, exclamation mark 8953. Your effective password is going to be shortened to 14 characters, and it's going to turn all the lowercase characters to uppercase characters. Now this is already bad, but realize that it mentioned earlier that we split the password into 7-character chunks. So we just take the hash of the first chunk, 7-character chunk, and the hash of the 2nd-character chunk, and we append them together. So what ends up happening is you can just pre-compute every 7-character password of uppercase and numbers and symbols, and you can just compare the hash to figure out the password. So this is the LM hash, which is really, really bad, and that's why we don't use it anymore. Okay, so now we're going to get into some tools for cracking passwords. Yeah.
I'm loud enough. Oh, sorry. Okay. I think Minh talked earlier a little bit about if you have a hash, you can't go back to the password. So most attacks are brute force attacks, right? So unless the hash function is poorly designed, which I recommend looking into, by the way. For instance, a lot of the hash functions that we use, MD5 and others, very poorly designed. There's internal state you can exploit. So we might run a meeting later on how to design a good hash function. Anyway, so to brute force hash functions, there's a great tool called Hashcat. Extremely fast, uses the GPU like Minh talked about earlier. GPUs are great for hashing. Hashcat is mostly how you'll be solving today's challenges. So 3 main switches you should know are on this slide. Minus M gives you, well, which hash function to try in general. So 0 is MD5. The ones after that are SHA and so on. Minus A chooses the attack mode. In general, you'll just use 0, which is a plain brute force attack. What are the other attack modes? Well, you can have things called hybrid attacks where, let's say you have some sort of standard list like raw queue, but you know for a fact that this person has 1, 2, 3 at the end, right? So you can write a sort of, well, it's not a rule because a rule is a different thing. You can write this thing called a hybrid attack where you'll say, well, every single password you check, append 1, 2, 3, and then check it. So one of our challenges is like that. It's, I think, Hashcat 2. So give it a try. Minus H is help, and that'll tell you exactly which codes to use, the nums on the slides.
Right.
Yep.
Another thing to note is that for the hash mode, so for example, we have -M0 for MD5. When you're cracking a password hash, Hashcat is not smart about, it doesn't really know which hash to crack sometimes, because there's a lot of different hash formats. So before you start trying to use Hashcat to crack a hash, make sure you identify what format that hash is in. So there are some sites that can analyze your hash and tell you what format it is in, or you could do hashcat.page, and it will tell you all the password hashes, all the password hash functions, and like what their password hashes might look like.
Yeah, there's a question in the Zoom chat.
Oh.
The question was back to LM hash.
Yeah.
Was this hash actually used for hash?
Yes, it was in older Windows systems. Yeah, I don't know what else to say. That's kind of embarrassing.
Next
Yeah.
slide, I think.
Yeah.
Oh, yeah. So this is, I feel like all of you are more than smart enough to figure this stuff out. I mean, probably y'all are familiar with the command line. In any case, this is some usage. Hashcat. So the first one is just, you have a hash, you have a dict. You just, try everything in the dict and compare it with the hash. There are more. So a hashcat rule is kind of like a regular expression. Now, why not use a regular expression to modify your word list using sed or something, and then give it to Hashcat? Well, because Hashcat is able to optimize these regular expressions into something called rules that leverage hardware to make this way faster than making a larger word list would be. And then the brute force hybrid attacks, like we talked about earlier, hybrid is misspelled. Next slide. Oh, yeah. You will need PDF to John in one of our challenges. This is just to show you that Hashcat doesn't necessarily have all the tools that you need. So in general, yeah, I agree with what's up on the slide. You do not want to be using John the Ripper. I found it pretty hard to get running because of some driver issues. But it has these two tools. They're really Python scripts called zip to John and PDF to John, which how many of you are familiar with the idea of encrypting a PDF? Great. So PDFs can be encrypted, and this is written into the PDF standard that Adobe publishes, right? So these tools basically look at the PDF and extract the hash out of it. PDFs are generally horrible binary formats that you do not want to parse manually. So yeah.
Yeah, so just like zip to John, PDF to John, what you're doing is you're just extracting the hash from the file that you have, and then you can crack the password hash.
Yeah. Be careful, by the way. The format that PDF to John and zip to John use are specifically made for John. So if you want to use the hashes that come out of there with Hashcat, there's certain modifications you have to do. All right. You can look those up. They're pretty simple. These tools, I mean, it's a hash at the end of the day.
Yeah.
So some small changes in some cases. Yeah.
Okay. And then one last thing is instead of using Hashcat roles or Hashcat hybrid mode, you can just use Mentalist to generate a text file with all the password combinations that you want. And it's an easy to use GI program, so I totally recommend it for beginners. So you just start with the base word list of like a bunch of let's say we're cracking a password and we know it contains some variation of a European car, a bunch of like a few numbers at the end, so 3 numbers at the end, and maybe 2 numbers in the beginning, or similar at the beginning, the European car, and 3 numbers at the end. So with Mentalist, you can create, you will first create a word list of like European car brands, so like like Ferrari, stuff like that. And then you can use Mentalist to prepend like symbols. So, and then you can specify how many symbols. So one symbol in this case, you add your word list, and then you can append 3-digit numbers. And then that will generate a wordlist.txt file that contains every single possible combination. And in general, you still want to use Hashcat rules or hybrid mode instead, because you can just type it into the program command line, and you don't have to have like a 30 gigabyte file to crack the password. But Mentalist is great if you're for beginners in this case. It generates a word list and it's easy to use.
Again, if you want to go fast and you have a really large word list like RockU, you probably don't want to put it through Mentalist because rules might be faster. So.
Yeah, so that's pretty much it. We will put these slides up in the Discord, and then you can check out the resources here. So you're definitely going to want to download Hashcat. You're going to want to download the RockU.txt word list. And then if you want, you can get Mentalist too. We don't use SecList for any of the challenges that we have, but I just thought I'd throw it up there because it's really useful. It contains a lot of different word lists that RockU might not cover. And yeah. So next meetings, the next Sunday seminar is we're going to do lattice attacks on RSA, and then right after we'll do a spray paint social, the spray paint social that we mentioned earlier.
Come to the lattice attacks meeting. It isn't as boring as it sounds. No, people need to show up.
All right. Okay, so there are a bunch of password challenges on the thing. I will upload these slides.